In this video, we're going to assemble the Master System 4x5 roll paperback. I'll try and go over how the mechanism works as we put it together. This is going to be the order of this video. 1, the body glue up. 2, the lid rotor glue up. 3, the Darkslide glue up. 4, the roller shrink wrap, which I think I shot in a different video I might cut in. 5, the lid assembly. 6, the counter assembly. 7, the pressure plate. 8, the roller bridge and lid lock and spring. 9, the wind knob crank spring assembly. 10, the crank and feed knob. 11, all of the frame counter. These face mechanics is 11. 12, the bezel and faceplate. 13, adding the counter. 14, then I'm gonna record tools and materials, but we'll do tools and materials right after this. And then finally, we're gonna do loading and use. We'll take a look at some use videos from in the studio too. Here are all the tools that you need to build the roll paperback. First of all, you're going to need some Weld-On 3 and a plasticator applicator, one of these squeeze bottles with a 23 gauge or something like that lure lock blunt tip applicator. And you're going to get yourself a pair of gloves. You're going to want an electric screwdriver for sure. Not a big drill, just a gentle, slow, but faster than an Allen key, and a hex driver. I think this is a 2.5 for all of these M3 hex cap screws. Next thing you're going to need is some way to cut 3mm stainless steel metal rods. I use this Channel Locks electrician pliers. I just put the rod in here. You'll see me do that clip. This is really good. You could use a Dremel, a bandsaw, a chop saw, anything, but this is probably the cheapest, easiest, most people have it lying around type of tool. You're going to need some crayons. They work great for lubricating things. You're going to need a small set of needle nose jeweler's pliers. Maybe just one will do. This will help you bend some springs and mechanics. Along with those, you're going to need 1 or 2 set of forceps for attaching springs to the lockout mechanism. I like to use these 2 1.5mm stainless steel rods just for alignment pins while I'm putting things together. They're very useful. And then, not necessarily needed, but you may need a little pick or something small and pointy. I have these dental picks in my shop, and I have a needle file. These guys are useful if you don't get a perfect print every time, just to smooth things out and or pull a little bit of the support material out. A heat gun, and that's all the tools you need. Ta-da! In addition to the 3D printed and laser cut components from the printing and slicing video, you need this hardware. We'll take a look at each piece as we use them in each section. You know, I think it is quite possible that we're going to see a new age, a new analog age, made possible by digital technology like 3D printing and laser cutting and home cottage industrial design. I'm not designing for industry. I'm designing for somebody else's house, maybe. There are slicing instructions for everything in a separate video. This is the only component that needs to be printed with support, and I'm using multi-material support. Okay, I'm going to get a macro shot of pulling off this support here. Wow, so easy. That's a really good benefit of using the AMS with the bamboo printers. Got a couple of hooks and needle nose pliers. Boop. That came out of here. Yeah, just like that. Boop. Now we've got this spot. Little secret about this is if these posts break, it's actually fine. You can just remove them and still use this shuttle lock. I've done that before. It works no worse, but anyway, it's a tricky print. Okay, now I have this shell. We're going to glue the shell up, and the shell is glued together for a number of reasons, geometry reasons, but also just like making a nice final product that is strong and durable and good at what it's supposed to be good at. So the first piece is this guy. If you've got this guy towards you and this away, and this piece, the thick sides over here, the thin sides over here, and they just stick together like that. Yeah. And then the next component is just this piece. It seems so silly that it's printed out separately, but I assure you it is for light baffling reasons and also print quality reasons without having to use overhangs or support material. Every face of this component is a nice face, and I try to really maybe sacrifice a little assembly time for a really quality product on this one. This guy goes in here like this. Make sure you get it right before you start gluing. Talked about this in the processor video. I use one of these plasticator applicators, and it's got lure lock tips, 23 gauge pre-bent flow tips. Use a couple of these in the course of this project. Weld-On 3, it's a solvent rather than a glue, so it'll actually melt the plastic and then it'll evaporate off. It'll flash off and leave you with nothing but the plastic. No glue in the middle holding it together with any sort of mechanical, chemical bond. It's just melting PLA to PLA or acrylic to acrylic. It's very good. It has some peculiarities about working with. It's a very volatile liquid. The gloves are just a suggestion to it. So I try and just not get it on my hands. Anyway, it's so thin and it runs so fast that you just want to hold everything together and then let the solvent flow. So let's just boop, put a little in there, let it flow into the joint. I'm just putting a little bit in the way of like tacking it together, and you can think of this process a lot like welding, like metal welding. There you're using, you know, heat and electricity. Here you're using chemical welding. Once your corners are welded, you can flow in a bead of weld-on and let it wick into the joints. Trying to be careful with this stuff. It will mar surfaces if you drip it anywhere. I'm also trying to do a nice job in terms of coverage. Get everything all stuck together as it should be. The next component we need to glue is this guy. So it's just going to align, you know, this hole with this hole here. There's a tiny little lip right here. Point to with my pencil right there, and that lip is going to help you align this side here. Boop. Alright, so this side is aligned to this ridge, this side here is aligned to this side, and then of course all of these four inside sides are aligned here. Get one little bit of it tacked on, and then we can flow in some more and make sure that it's nice and tight. I'll put a little bead along here. This is not the most efficient in terms of manufacturing time way to assemble something. However, it makes an extraordinarily strong, light, tight component. It allows me to do some things that I could not otherwise do. Print it on your 3D printer. Now, as that's drying, I can check the alignment. Alignment's good. I am going to put in light seal bars. These two laser cut polypropylene sheets or hand cut polypropylene sheets, and these two triangles. Here's how they go together. First, we're going to do the inside one and these holes aligned with the buttons, and then we're going to put on one of these triangles like this. The polypropylene does not melt with Weld-On 3, and that's going to allow us to melt weld the top piece to the base and leave this springy light seal in place. So I'm just adding some Weld-On under these guys, and they'll just stick right together. I'm going to press, and then I'm going to just repeat the exact same thing on the outside. It's much easier if you go inside outside rather than outside inside. Just about getting your fingers around. Alright, I'm going to take a minute to let this dry so that this is nice and hard, and we can test these light seal flaps with one of these Darkslides like that. But I'm not going to do that. I'm not going to apply any stress to it until it's hardened. I'm going to give it at least, 5 or 10 minutes. Really, it should have a few hours to harden fully before you really start stressing it, but you can check it in a few minutes. I've given this a few minutes to get pretty strong. Really, I'm not going to keep this in here, but I can just make sure that, that I can slide this guy in and out and that it's smooth and good. Okay, great. Next step is we're going to take this face plate and just stick it here. It'll click into place in the right spot, right? Boop. Then I can test this again, make sure that my Darkslide goes in and out. Okay, great, it does. Now with this clicked into place, we're going to flip it over, and I'm going to hit it with Weld-On cement in this corner here with the back facing like this on the table. I'm going to put a bead of Weld-On 3 there, and then the same on the other side. So let's see if we can see that without me dripping too much and making an ugly mess of it. One, again with the awkward bloop. Oop, did I get it everywhere? All right. Okay, it gets glued on 3 sides. So it's the 2 sides, and then here along this seam. Just do that very carefully. Try not to make a big old mess. Just a little old mess. Little old mess. Okay. Push it down. Make sure everything is right at the correct flange distance. I do love printing with these bamboos. Everything's exactly the same size and shape every single time. It's really a new era of 3D printing we're in. Okay, so now you could stick this back in, but at this point you would just melt the acrylic, so I urge you to wait, 20-30 minutes before you go messing around with this. We'll confirm later. The next glue operation is to put on this piece and this lock bar. These are part of the light baffle and lock system. They're standard Graflex parts. This guy and this guy. This larger of the lock bar has a round corner here and a square corner here and here. The round corner is going to go up at the top here, like that. This guy has to be aligned. Glue with one hand while I film with the other. Highly inadvisable. No, I'm going to put this camera down. Sometimes it makes sense to use gravity as your friend when you're doing some of this gluing. Alright. Here we go. Get those 2 corners on, and then I'll just flow a little bit more in here, and it'll wick in. But it's very slightly wider than it is tall. Alright, so this is part of this line here in the film backs. This is part of the camera kit, or if you're just using a regular film back. This bar here has always been there. It's part of the locking system to keep the holder from sliding out, but it's also part of the light baffle system to prevent any light coming in here. These are going to line up so that when this guy's in here, right, this lock bar winds up boop in there like that, which is the same as if these guys are together, it's that, you know, just over the whole alignment. That much space is 18.3 millimeters. The way I like to do this is just put one dot on the end and then, oops, just tack weld that, just like everything else. Just doing the corners first, get it into position, and then you can check its position and then flow some more weld on to finish the weld. Yep. And then so I can check this now to make sure. Oop, yep, that's a good fit. And then I can also check it against one of these. Boom. Yep, yep. Okay, so now that I know it's in place, I can go ahead and just weld the whole thing to the face. For now, we can set this aside and come back to it when it's dry in an hour or two and test. Okay, so you can test this real quick while this is drying, but don't leave the slide in there for this to, you know, off gas and melt everything together. We're here. We might as well glue up one of these. Okay, the Darkslides are 16th inch acrylic that's been laser cut. Maybe I'll sell some of these, or you can laser cut your own, or even 3D print a version of this, maybe out of carbon fiber PETG. There's a few laser cut components that just make it much nicer. Okay, these are the Darkslide handles. They have like a dish for your fingers for a nice grip. They have a square side and a rounded side. The rounded side goes up. This is the rounded side. Oops. This is the rounded side up here. This is the square side here. In position, hold one of them in position, align with my fingers, squeeze it real tight, flow a little bit of weld on in there, and Bob's your uncle. All right, we'll do the next side. I like to leave the protective film on while I'm gluing so that I don't get any rogue glue spots anywhere, that it's nice and clean when I peel it. Here we go. And squeeze them all together. You can redo the alignment a little bit if you need to while they're still tacky, but really just want to squeeze them and keep them in one place. And you can peel off this guy. Bloop, bloop, bloop. All right, that's how you make one of these guys. Now we're going to look at the rotors. These are the lid locking cam spline rotors. There are two rotors like this, and there are two other pieces, whatever these are. These pieces are the rotors. You'll notice that there's an alignment line. One goes to the corner of the hexagon, and one goes to a side of the hexagon. We're going to do the corner one to the one it lines up with. They're both the thicker of the two. Take a little squeezing to get together. They're supposed to be tight. They're going to be bonded. And then this, the shorter guys are going to go together like this. And these alignment marks do align. From there, it's pretty simple. Just on their back sides, we're going to run a bead of weld on 3 between them, and they should be tightly bonded. Okay, we can set those apart to dry, and we're done with weld on 3. Okay, I think I'm going to cut in here how to shrink wrap a roller from my last video. I'm going to put black rubber on because it is part of the light seal system of the roll paper back. Just going to work my way around. This is, again, 1 inch, 3-to-1 shrinking, rubberized shrink wrap. Comes in long rolls of this tubing. I work my way around like a kebab. I try not to put any twist in it, try to get it nice and smooth, but also I'm not trying to overdo it. You gotta You gotta have kind of a okay touch with it. The rubberization just helps, you know, flat rollers catch flat, non-sprocketed media, paper in this case. Gives it a little gription in the machine. It's nice. This is a good technique. I think you could probably use this for like typewriter parts and actually all sorts of rubberized rollers. I give away the trick. You don't even have to buy the files. But you should buy the files. $99 at CAMERADACTYL.com. You should be building one of these if you're watching this far, geez. Alright, and I'll leave the trimming of that one to next time when I put together the roll paperback. It has to be trimmed to a specific length for the mechanism, and I don't know that right now. To put the lid together, you need bop, boop, beep, bop, bleep, boop, boop, beep, boop. That's it, B. Just this stuff. This is your lid. This is what we're making. Boop. These two knobs. We're going to need these two rotors that we just glued up in the last step. We're going to need this little locking transfer gear and this gear axle stud. But then you're going to need 3 M3 by 10 millimeter screws. Those are going to wind up here. Bloop. And then you're going to need 12 M3 by 20 millimeter screws for this guy and this guy. Let's put it all together. We're going to use the lock here and its rotor. Which is its rotor? Its rotor is the thick rotor. That's this rotor. Okay, so now there's something important to note. I said I would go through the mechanics of this thing, and I guess here's the first explainer point, really. These semicircular cam grooves limit the motion of this plate, namely to 57 degrees in one direction, right? They interact with these bumps here and here, here and here. So you can put this thing in backwards, right? It can either go this way or it can go this way. And I should have made them slightly different diameters so you could not assemble them wrong, but oh well. So when you're looking at this guy like this, the thick cam rotor goes like this, and this is not the way it should go. This is backwards because this line is actually an alignment line. When we're going to put it together, they're all going to be facing this way, right? Much like my already built version. When it is unlocked, it's in this position. Okay. When it is locked, it's in this position. So what I'm going to do, when it's in this position, this locking arm on the knob is corresponding to the hole. So I'm going to rotate this. Aligned is all the way one way and all the way the other way in that same mounting position. Puts this guy aligned there. Here's a tool that I like to use. It's just a 1.5 millimeter section of rod or wire, and I use these for aligning screw holes for bolt-up jobs such as this. Pull your knob down at the bottom and you can align these guys, and just once you do, check to make sure that we've got everything in alignment. Yep, we do. Okay, that's a happy little tray of bolts. Okay, these are M3 by 20 millimeter hex cap screws. Okay, and we can check, yep, that moves smoothly and there should be no gap between these. Great. Okay, so now I have a knob that ends here and here, boop, boop, and a rotor that ends here and here. The next thing we're going to do is add the transfer gear. We got that gear stub, the gear, and these 3 10 millimeter bolts. Here's a good time for me to introduce this concept. Crayon is a really good lubricant for a lot of these plastics, namely PLA. And so if I'm printing a bearing surface, this is not a high wear surface. It's just during a lock and unlock during the loading, right? It's not always spinning, but you can still make it really nice with a little bit of maintenance, namely drawing some crayon on. I keep white, black, and gray crayon on my desk, but you can use whatever color you want, really. These are relatively inconspicuous in my white, black, and gray parts, but they'll just make it all go together a little bit nicer. I'm going to use these alignment pins. Again, these are 1.5 millimeter stainless steel rods that I happen to have laying around. So these are 10 millimeter M3 hex cap screws. Okay, now this guy still rotates nice and smooth, and these guys rotate together. This step you're going to need 6 20 millimeter M3 hex cap screws, just like the other knob. How this is going to go? Okay, with this guy away, this is aligned here. This guy should be aligned here. Now we know it's rotating in its cam limited, these cams and these nubs, cam limited sector. Then we're going to go all the way away from where this is, and this guy's going to go all the way away as well. Now it's important that we keep everybody like this. When we, oops, I said when we keep everybody like this when we flip this over. All right? I'm going to use these alignment pins again. All right, and then using this knob has a gear sector from here to here, right? These gear teeth, and then just a knob sector. We want the gear sector to be facing up and limited at the end of its travel like this, and still lined up with these alignment pins, right? There's only a couple of options for the ways that, 6 options for the ways that this thing can be mounted. This guy's going to be something like that, you know, like this, but we're gonna use those pins. It's at the end of this gear's travel. Yep. Okay, now if I hold these pins in place here and flip it over again, we can see that we're right at the end of this travel and we're aligned in the center. And flip this guy back over, put it on its head, and then use 6 of these 20 millimeter M3 hex cap screws. Okay, now you should have a lid that rotates from these 2 lines connected to a part like that, where this arm goes from here to here. Bloop, bloop. And the gear sector of this knob is completely used in its travel. Yep. So these inner cam spline rotors, let's just talk about how they work and what they're doing. Inside of these rotors, they each have a set of teeth. That's the spline that interacts with the paper can. And we'll look at that later. On the outside of the rotors, they each have a cam. 1, 2, 3. 1, 2, 3. Those cams lock the lid to the body here. Let me turn it. If you can see in here and here, and then later on part of this mechanism is actually in this bridge we're going to install in a later step. And then there's a slot here and here again in the bridge, and one over here. Anyway, those should interact, and so at this point you can take your glued up body and just, this should be open when it gets dropped in, right? Boom. Yeah, that's nice. Let's get a good view of that, right? Boop. and then it should turn and lock. And it won't lock as securely as when the roller bridge is installed. You know, it can still lift up on this side a little bit because those have nothing to engage with, but this guy is just, it's on, right? Working, we will check it again later, but we're going to put the lid to the side now. This is what you need to assemble the counter. 3 M3 by 12 millimeter screws, 1 laser cut acrylic faceplate or 3D printed version, 1 ones place counter wheel, 1 tens place counter wheel, 1 little transfer tally gear, and 1 counter housing. Alright, so the way these are going to go together, I'll show you real quick, and then we'll actually do it with camera precision in fitment. This guy goes in here, boom. This tiny little gear here, it's got 8 teeth across the top, and across the bottom, it's got 4 teeth. When we mount it, 4 teeth go down, boop, like that. Then we've got the tens place, that mounts inside here like that. Then this guy goes over here. But before any of that, the bamboos are not yet quite at the point where such a small, fine mechanism doesn't need any handwork before putting it together. So, the first thing we're going to do is just make this tally gear perfect. There's a lot of time and space constraint issues here, but I'm going to take our bolt and run it through and just like move this up and down. We're using the threads just to sand the inside. And this is actually a very good place to bring in our old friend Mr. Crayola Crayon and add some crayon to the threads of this bolt that we're going to wind up using as a pivot for this tally gear. Okay, we can set these. Well, actually, let's just see. We should be able to push it on and then just eventually spin it pretty freely on here, yeah. Yeah, that's a nice freely spinning gear. Okay, the next thing we're going to look at is the interaction between these two. The tens place sits inside of the ones place, and so these should spin freely. Because of the dual color printing, there's some small inevitable slicing artifacts. Again, I'm playing a game of like the minimum resolution of this printer in this object, but just requires a little bit of handwork here to grab the inside like this and just grind them together a little bit so they move smooth. They're never going to get this much force being used as a counter, right? But you can just wear them in so they wear smooth really quickly with, you know, our giant human strength. And this is with no crayon. I'm using the material to grind itself nice and smooth, right? See like how you grind a camshaft bearing almost. You can just roll the outer coin edge of this, you know, tens place here and just sand it a little bit. Get it really, really smooth so that these guys provide no back pressure in the system, provide no resistance. Smoothnicity is the name of the game for precision. So it's actually going to touch a little bit on these outer faces, and then it's going to touch on this flat face, so you might feel here and give it a little. Okay. It really doesn't need much, if any of that. Okay, yeah, you can put your finger through there, and then it should spin with no resistance. And then this is also a nice place to add some crayon. Boop, 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 boop. And I would add the crayon to even these surfaces in here, maybe especially the little tally point, the one intermittent counting tooth. Okay? This is a pretty standard mechanism. This is not a mechanism I designed, for sure. There are other even 3D prints with this mechanism and counting things, but yeah, pretty standard style of counter. It might make sense to grease all this up. It doesn't need it in here. Ideally, nothing will touch, but if it does, anywhere where you're going to have a bearing surface, namely the outside of this stud right here, and even the bottom plate, where you have a little bit of the ones place rotating, a little bit of that, a little bit of this under your hand power will really make everything start to move very nicely. Okay, so now you can drop this guy in, 4 teeth down, 8 teeth up. 4 teeth bad, 8 legs good. Okay, and then so here's how this counter works, although there are definitely 3D printing and mechanical engineering channels that go over much more complicated counters, but how this one works, right, is every time this little groove tooth here goes around, it actuates the tally gear. Yep, you see how that only moved there when this tooth passed by, and here that tooth's going to hit the tally gear. Come on, it's hard because we're not on a pivot yet, so we can just wedge it by knocking it off axis, but there it seems to be going even while wobbling around. Then we can take the tens place and drop that in, and then I think this will bind without a pivot, but it should go like smooth. Yeah, it's going to bind a little bit without a pivot, but every 10 ones it should just click over the tens one. Yeah, there we go. That's working. It gets a little bound up because I don't have a pivot screw in the center of the tally gear yet. That's the next thing we're going to do. So anyway, when you get all this moving reasonably smoothly, we're going to take the face plate. My bad. We're going to amend that to just 4 12mm M3 cap screws. Got a bill of materials, but so much preparation. There we go. Alright, that's 12mm. Turn it enough so that it catches, and then we want to make sure at this point that we can rotate the ones place and it'll take the tens with us. And ideally you should be able to just spin this like that, and at first it'll definitely have a couple little hang-ups for a second, but it'll wear itself in. If it hangs up really hard, you're going to have some problems, but it really shouldn't jam or anything. It should just keep going around like this. I like this smoky acrylic that you can see through. You could use a 3D printed plate that you can't see through, but I like seeing what it's doing if muted. Okay, so when you're working it in, like here I'm finding like a little catch. I can just work this area back and forth a couple of times, and that'll, either get enough crayon in there or bust up a burr to the point where eventually it just really begins to move very smoothly. This is about as much working something in as I had to do on these bamboo prints, which I really appreciate. I'm going to put in the other 3 screws. There's one more screw hole for the pivot. That's this one back here, but we're going to leave that for one of the last steps in this assembly. Here's a word of warning and something that I did. You can put the tens gear in such a way that it will never line up, ever. It will always be between half gears like this. Always be between half numbers. So the solution to that is I need to take this apart and rotate this guy just one tooth, and it'll be back in phase. make sure that our decimals are working. Yep. And I think that'll even work in to the point where I can just spin it across 20, 30 numbers. It's plenty smooth enough to work as a good frame counter. There we go. Alright, the next step is we're going to mount the pressure plate. We've got the body back again, we've got the pressure plate, and we've got the two PETG springs. It's important that these are printed in PETG, they're springy. So on this island structure here, we're going to mount 2 of these PETG leaf springs with 4 M3 by 10 millimeters hex cap screws. Notice these are asymmetrical and they go in like this. The short end over here. As in, they've got a little bit of a bounce. Up here, we're going to slide in this pressure plate with the countersunk holes towards the front of the pressure plate. Then you have to push the pressure plate in this way a little and slide it down past the bottom rail. Should be in some minor tension. I might use another one of these alignment pins here. And then I need 2 M3 by 8 millimeter hex cap screws to hold the pressure plate to the leaf spring. Great, now we can see pretty clearly the pressure plate is abutting against this rail tightly and this rail tightly as well. For the next step, we're going to need the shrink wrap roller that we made earlier, the idler roller that has no shrink wrapping, the lid lock button, the roller bridge. We're going to need this spring. This is a 23/64 by 1 3/8 inch spring. And then we're going to need 2 304 stainless 3 millimeter in diameter rods. One rod is going to be 137 millimeters, and then the other rod is going to be 123 millimeters. These rods, I've tried to cut them with Dremels before, and bolt cutters and all sorts of things. If you assemble the photo processor, I'm using a lot of 150 millimeter rods standard, so I'm taking these, I'm measuring them very carefully with a caliper and marking them with a Sharpie. In fact, let's make one. Let's zoom in here. We're gonna go for 123. I'm just gonna make one real quick. That's good enough precision for what we're trying to do with this part. It doesn't need micrometer precision. And look, I've tried everything. You could cut this in a bandsaw. You could cut this with a chop saw. A chop saw would be great, or bandsaw would be great. You could cut it with a Dremel or an angle grinder. I really like these. They're Channel Lock 369s. Jaw. Boop. Boop. This is a really lovely pliers. Channel Lock 369. They did not pay me to say this. They're just electrician's pliers. A pair of Kleins would probably work. They just make quick work of easy cuttings. Boop. Boop. Come on, focus. Yeah! And you'll need 4 M3 by 16 millimeter hex cap bolts. What is step 1 here? Step 1 is to take the spring and drop it in the hole. This hole has a little circular depression. I don't know if you can see that. down at the bottom. That's where this spring needs to be. Bloop. That spring is seated in that circular hole. Once that's in goes this button. This is the lid lock button. Make sure it moves smoothly. This is another great candidate for something that you might take a little crayon and just rub it along the sides that are rubbing, and it'll just make it a much nicer, smoother, awesomer user experience. You're gonna love it, I know it. Okay, so the shorter of the two and the idler roller go together, and then this guy goes into this depression right here. That is where the idler roller goes, and the driven roller, or the driving roller, the metering roller with the shrink wrap goes over here on the side with the hole for a pivot, and the idler roller just has its 3mm steel rod go into that blind hole. Get the rod in, boop, and then drop the idler over it. Skinnier fingers than mine might be a little easier. Okay, that's one side, and then the other side is this wrapped roller. When you shrink wrap this, you need to make sure that you cut the shrink wrap at this end so you have at least 1mm of no shrink wrap on this side, and then this side you need 6 or 7mm of balled no shrink wrap so that this can fit through the light baffle geometry inside of here without causing extra friction from this rubber out of place. So this one is going to go in here like that. Now with this roller through its hole and this roller on its pivot, both of these guys here, we're going to slide this in, and you're going to need to get each of these rods in their hole. It's a little fiddly. Maybe you want to use a forceps or something to grab hold. Great. So now that pin is in the hole. So I can actually take this out for now. I also want to make sure that this is through there like that. Okay, great. I can't put this down on this side just flat on the table because it'll push this roller out. So what I'm going to do is take a shim, a high-tech assembly shim, put that down like this, and now I can put my whole assembly on top. The spring from this button is going to want to lift the bridge off of the rollers, so we're going to need to push down. So these are all 16mm M3 hex cap screws. Okay, so now we should have a good pushy button. This button should top out over here. There should be no like wobble. The spring should be firm, pushing the button against this guy. All of these should be in and flush. Your idler roller should be captured and spin freely like that. This thing's not going to work unless you can make that really spin nice and smooth. Like, yep, I just can't get my finger in there, but it does. You can feel that it's loose. And then this roller, there we go. So now I've got this seated inside of the bridge and poking out the top here. We may pull this out during assembly, but eventually this is going to sit in its own little pivot, and we'll see that later in the assembly. But for now, I'll put this finger here, and then we can see this roller should be able to roll freely. I'm spinning it with my hands on the inside, but that's a nice fit. Yep. And you might even put some crayon in here, but that shouldn't be necessary. Look at this. We're going to put together the wind crank. You need this arm, this roller knob, the wind crank itself, and a PETG spring. You'll also need one 40mm M3 hex cap screw and one 16mm M3 hex cap screw. First thing we're going to do is put the crank together. The crank has a bump side over here and a flat side. We're going to put it flat side on its back and countersunk hole side, this side up. And then we're going to drive a 16 millimeter M3 hex cap screw in here. Not all the way tight, just enough that this thing can roll. Boop, 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 boop. This PETG spring has two sides. It's got a flat side and a slide with a slight bump. That bump engages to keep tension on this piece here. So we're going to put this in. Once you put this in here, it'll pop in, it'll never come out unless it breaks. You can break it and take it out, print another one, but you want to put the flat side down and the bump side up. You want to put this side towards the center of the crank and the open end of this spring towards the outside. I only do this once. I'm trying to get it in focus. Boop. Just like that, and you just push down and boop, clicks into place. Not going anywhere. Do is stick this guy here with the 40 millimeter M3 hex cap screw through. There's one side that's countersunk for the bolt, for the screw head, and then one side that is not, but it goes all the way through. Okay, now this thing should pop up and lock into place, and then pop down and lock into place. That is the wind crank. Now we're going to put on the wind knob and the feed knob. We're going to need the whole housing now. We're going to start building the mechanism onto it. And we're going to need two M3 by 25 millimeter hex cap screws. Let's start with this feed knob. We're going to take this spline with the square or square edge hexagon plug, stick it through here. This is the hole over here by the counter slot. You see that? Sticks right on there. Boop. Great. You can absolutely put some crayon wax on this pivot, but you really don't need to. I prefer not to. And then we're going to do this guy. One thing I like to do for extra strength, because there's not that much meat in there, is actually just use a drop of weld-on when I make this connection, which will mean that if I ever have to change it, I will have to print a new one of these guys and one of these guys. But so far on all of my backs that I've glued, this has been just like a permanently, awesomely strong piece. So I'm going to glue it through the wall here as like a cheat for super extra strength, but it makes it a little fiddly because I don't want to glue any of these parts to the base here. So I'm actually just going to put a little bit of Weld-On 3 in here, right, just so that this surface is tacky. And then I'm going to come in from the top like this and plug them together. Just hold them for a sec while just those surfaces melt together. And make sure it still spins freely from the rest of the body. I did get a little drip, so I don't want to keep it moving. Okay, so now we've got this guy screwed in here, and we've got both of these knobs connected. Let's get a close-up shot. All right, now. I've lined up this back with all the parts to put it together, but before we do that, let me just give you a quick demo on how this thing works, how the mechanism is operating. So when you crank, let's see if we can see, when you crank this crank around, right? this winds the film. It can only go in one direction because of this ratchet pawl. This pawl is sprung. There's a spring, we're going to see it, and it allows it to move this way. And when it moves this way with the gear, it locks the gear. I don't know if maybe we can see that, right? And in the other direction, it lets it move. Also, when this gear is moving, you can see this blue lock wheel will also turn around. We'll see its function later. Okay, when you crank that crank, it's going to pull paper into the take-up cassette here, right, through this spline. And it's going to drag paper from the feed cassette, which is going to go here, around this metering roller. This is the roller that we already shrink wrapped in rubber shrink wrap tubing. Anyway, the paper is going to roll around here. And what happens is the top of the metering roller goes through this yellow gear, and it turns the yellow gear. Now that yellow gear is going to interact, one, with this counter mechanism, but let's forget about the counter mechanism for a little bit and just worry about the metering mechanism, the frame counting and lockout. The spacing mechanism is this guy. So what happens is, let's zoom out, as you crank, nothing's going to happen until I fake my finger because we don't have paper. As you crank, you pull paper, and that's going to move paper around the metering roller and turn this yellow gear. Now this yellow gear interacts with this red gear. It's the same as this black guy right here. And that's actually a 3-layer component. On this bottom, it's got a cam. In the middle layer, it's just got a regular spur gear. And then the top layer, it's got another cam. And we'll see that function in a minute and how it relates. But what we need to know for now is that the gear layer meshes to this yellow spur gear on top of the metering roller. So every 2 rotations of the metering roller, we go 1 frame. That's about 6 inches. And it'll be 1 rotation of this logic wheel. Yeah? Can we see the logic wheel rolling? The logic wheel is this red guy, or this black one. The black one is what we're going to install on the one we're building for this manual. So now you have this lock shuttle button, and then this trigger lock over here. The trigger lock is pushing against the shuttle button like this. We've got a shuttle button and then this trigger lock, and one is sprung against the other. So when it gets pushed down, it goes click and prevents it from popping back up until, let's see, this little nubbin here on this logic wheel comes around and knocks it off. Right, so this will come around once and knock this guy off like this, and its spring will pop the shuttle button up. And then this shuttle button has a pin, a lock pin. You can see the screw right there. And that will stick into one of the holes in the lock wheel, locking out the crank and making sure that you can't roll any more paper until you push this button again and allow the lock pin to drop below this lock wheel and allow the crank to move again. So we can watch that happen. You're cranking, you're cranking, you're cranking. I've got my fingers in here pretending to be paper, and they're turning this logic wheel. The logic wheel here, you can see the lower cam start to interact with the trigger lock. The trigger lock opens and then drops the shuttle button onto the surface of this underside cam, and we'll see why that's important in a little bit. Now the underside cam slides off and releases this button and then soon the pin falls into the next hole on the lock wheel, and this is locked out. So we'll do that again. We've got push the button down, cranking, cranking, cranking. We've got paper coming around and moving the yellow wheel driving the red wheel coming around and opening the yellow trigger lock, and then the red shuttle button popping up and then locking the blue lock wheel, which then in turn locks the crank. All right, we can look at this again, and we'll look at each individual piece as we put them together. I'm going to start this by putting in the frame lock shuttle button, this guy. The first thing you need is one M3 by 10 millimeter hex cap screw. We're just going to make this into the locking pin on the shuttle. Here we go. Boom. You know, I absolutely could have printed a plastic locking pin there, but it's just much nicer with that little metal pin there, even though it takes a little bit more to assemble. You're going to take all weekend to do it anyway, probably. Take your time on this one. So it's going to go in here. It's got these 3 posts. These 2 posts could break off, and it actually doesn't matter. You just need this bottom post to go in the center hole, which is going to house this 23/64 by 1 3/8 spring that goes into the lock shuttle like that. And this guy is going to go in here like this and spring up and down. Now, if your spring is a little too short, which this spring is a little too short, I can just put a little anything, a bit of a pencil in there, or I can stretch out this spring. But really, what you need to make sure is that when this thing is bouncing up on the spring, you need to make sure that when the spring pushes the shuttle button up, that this surface has to be naturally proud or above this surface here. Right, the surface of the back itself. So this one's just sagging a little bit, and I need it to naturally want to pop up above for this lock pin to engage the locking wheel. Yeah, lock out this this guy. Yeah, okay. So this is a little too short. I'm going to grab a piece of a pencil. Here, I'm going to use those pliers. I've never used these pliers for this before, but cool. Just a little pencil nubbin. That was a little short one. Sometimes they're not too short. Sometimes they are too short. But okay, now this guy pops up proud of where it needs to be, and it'll push down below this level. This trigger here, must swing in when I push this guy down to hold this whole mechanism down below, and so that this guy can just spin freely. Once this moves out of the way, that's got to pop up and jam the pin into one of these holes. So okay, now that we've got that, actually before we do that, I want to add a whole bunch of crayon to this. This is just you know, mechanism wise it probably does not need the crayon. However, just the sound to my ears of the next 10 years of hearing this damn thing every time I press the frame lock release button, it's just going to move so much nicer and smoother. And then also over here where there's a sliding lock, we can lubricate that with some Crayola crayons. White, black, gray. It's great. Okay. Back in there. That back in there. That back in there. Okay, now we're going to use a 16 millimeter M3 hex cap screw. These are all the same type of screws. We're going to use a 16 millimeter one right now. Now when you push this guy down, if we turn this lock, it'll keep them down, and then if we open the lock, do that, right? And so eventually what's going to happen is, as this timing disc rotates around, this bottom cam, this bump right here, is going to hit this guy and go boop and open this up, so it pops up. The top here is actually going to get caught on this cam for a very specific ergonomics reason, but we'll get to that later. Gets caught on this cam, and then this rolls off just a little bit more, and then this guy pops up like that. Okay, let's continue assembling. Okay, so this ratchet pawl is going to be here. It's going to get a 16mm screw, but it's also going to get a very specific mustache spring that we have to bend, and it's going to get one of these 0.3mm by 2.5mm by 10mm tension springs. One of these guys. This ratchet pawl, which will allow the crank to move in only one direction, and the other direction it'll catch and lock. This pawl gets a mustache spring to bias it in a way that will push this pawl always against the crank ratchet, the crank gear, and then the other side of the mustache spring is just going to be wedged up against the inside of the cowling. The cowling will go about here, so there'll be like a wall here that this will be wedged against. In order to fit in this thing properly, you've got to make a couple of bends. So the first bend we're going to, yep, and then I'm just going to cut off the very tip of this bent mustache spring just because it's too long to exit. It's too long to exit right there. We got a 12mm bolt is going to hold this on here, but also we have one of these springs. This spring is going to also attach and just anchor to this. It's going to also attach and just anchor to this ratchet pawl, but it's going to pull this trigger lock, and it's going to bias it in this direction, right? It's going to pull it always this way, so that when the cam comes and opens it, when the cam passes, it'll snap back into a locked position. This is a good time to maybe work with a forceps. This is a pretty little spring. I've actually made this work a couple of times with the dental rubber bands from the processor assembly, but this is a much better spring. This will work for 50, 60 years. You wear everything out before this spring. This is one of the trickier parts to the whole thing. I guess I could open this wire loop up just a little bit, probably on both sides. Both sides have to go over an M3 screw in there significantly. So this looped on the neck of this guy right here. Now I'm going to go through and I'm going to make sure that this leg of the mustache spring goes in the slot of this guy, the pawl. Great. Okay. Now these guys can be screwed in. I'm not going to make this super tight, right, because I want the pawl to move back and forth. I just want to get this screw head down maybe to the level of this screw head. This leg will be eventually pressed here, and that's how that action will work. Great. And now this is probably the trickiest part of all, where we've got to bring this over here and screw it in. This is an M3 by 6 millimeter screw, and we're going to use this and this tension screw to attach right here to this hole. Oh! Okay. Now, upside down, backwards, away from me, can I get this guy hooked? There we go. Okay, so that should do that, and this should do that. I want to take this 5mm, 6mm M3 bolt screw, and I want to drive it down as far as I can go before it starts hitting the base plate. Right, I want it to go all the way to the bottom of the white trigger. Next, I'm going to do this little transfer gear for the counter and this top gear for the metering roller, and they go together over here. The way this guy goes is big gear up, and then it's got this plate level and then this cutout level. So this guy's going to go 8 teeth down, 4 teeth up here. And then this is going to go collar down, teeth up here. I should just push all the way down there. This guy should get a 12mm screw. The screw should go down until these guys are flush, but this can also move smoothly. So this should move one set every time the metering roller moves around, which it is. That's great. Alright, so I'm just getting this pin back in, and the pin should just stick out a hair up here, and then on top of this guy, this little top hat guy. Let's zoom in. Boop. It's this top hat guy, this round one. It's important. This will ride under the acrylic. I can use my alignment pins right now and drop the pins in, drop my lock wheel here, drop my this guy here, and then I have a little bit of just a little spacer that sits on top of the lock wheel there. Could that have been one piece? Absolutely. Is it more cool in 2 pieces? Certainly color-wise, yeah. This is kind of a crazy design, the way I made this. Especially this little bit of what I'm just going to show, like a tiny strip as wide as the gear teeth of this, of acrylic, all the way around this crank. But I love that detail. It's so cool looking to do it like that, and so I just did it like that. You're gonna spend days and days making this thing. If you save this much acrylic and lose that detail, like, well, I just tried to optimize for making it as nice as possible. So each of these gets a 20mm M3 screw. I'm gonna do the logic wheel first. And you don't want to tighten these so much that you bow the acrylic at this point. You just want to get them all the way down to keep everything in place. Yep. And do this one. Same deal. Okay, and then we can test some of the mechanics here by either, can I get my hand in there? Yeah, spinning the internal roller here. We can trigger the lockout, which is true. We can push the button down and then allow the crank again, and then we can we can grab this guy and push it down here to bias the crank. It seems like everything is working well at this point. So now we're going to build the cowling section. The next thing we're going to do is put in all of these bridge standoffs. There's 4 of them in the file set. Sometimes I call these 3 the bones, but essentially all of these things' job is to hold this acrylic plate up so it's nice and strong and sturdy. And also this one has another function, which we'll see. So let's do this one first. So I'm going to make sure to do it this way, facing you guys, the camera. I'm going to make sure to put this guy like this. And when I do it, this arm right here, it's going to need to go this way and push against the wall of this bridge. So just push that down. Grab it over here. I should be able to get it into position. And you'll note there's a little cutout here. It'll fit in only one spot one way. Now, the thing about this one is that this spring wants to kick it out, so I'm immediately just going to bolt up the 2 inner bolts here, right there and right there. This is an M3 by 16 millimeter, and the same with this one. I'm going to put these guys in, and that's going to hold this back spring, and it'll keep this guy in place. That guy's rolling good. This spring is this guy. It's a 7/32 by 1.5 inches. It's this spring. This spring sits in the back of the feed brake. I really love this super overkill mechanism. What this does is it slides into, there's a hole in here. I'm going to slide that in here, and then, come on, baby. Whoa, 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 whoa! Okay, so you can see that there's the spring is in the hole in here and in here in the brake, and all this does is continually push between this piece of PLA and this feed knob, and that has been always more than sufficient to keep back tension on the feed cassette on the paper, so that when it spools through, it's grabbing this rubberized metering roller, and we keep good frame spacing through the machinery. Okay, back to assembly town. Next, we're going to put in the bones. Yeah, I don't know what. I like these. They're such like little funny. The first standoff, I'm going to stick it in like that. Just sits there. This is the second standoff. It's going to go in here. Notice all of these standoffs have their own little box joint to keep them right in place. This is the third acrylic bridge standoff. It goes in here. It goes right here between the lock wheel and the crank, like that. So now you can certainly undo this next step. However, it's hard because it's a tricky fit to get all of this together, but once it does, this guy kind of like presses and locks to these standoffs. They fit in here, here, and here, and here. There are standoffs on this guy. There's the standoffs. Wasn't recording that last time. Alright, so these dovetails that I'm pointing to, they also go to the dovetails on the inside of this thing, kind of there, and there, and there, and all around this thing there are these little dovetail joints that are just going to slip together when I put this together. It's not that exciting if I get it aligned right the first time, but if I don't, it'll take a good amount of fiddling. One, two, three. Oh, yeah, what's going on? What's going on? Hey, sure. Okay. Before we screw in this cowl, bezel, whatever you want to call it, I'm going to put in one of these springs. It's 0.016 inch spring, but that's for Ethan's reference. Ethan, put the actual spring spec here. This guy goes down in here. Boop. There's nothing for it to align with. This little hole, if it is tight on this triangle counter lock, you may have to file it out a little bit with a needle file, but also really a good place to put some crayon on the lower part of this shaft. I'm going to use gray crayon. Boop. And then I can, ideally should have gone first, but pull one up, push the other down, and then go up and down like that. Okay, so this is the lock for the counter mechanism. 9 M3 by 20 screws to hold down the bezel. Doesn't really matter which order you put them in, but I like to do something like a star pattern, you know, boop, 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 something like that. Not all one side at once. Come on. This is an M3 by 25 millimeter screw. Let's see. I get that right. This is the pivot, and it goes down through this guy. And the counter just pivots in and out like that. So now, I'm going to put this to 0, 0. It's going to count back 2 frames when I push this in, and these gears rotate against this locked tally or transfer gear. So it's on 0, 0 now. It'll be on 98 when it goes inside. I want to start it at 0, 0, close it. It'll be a couple frames before 0, 0, and then we're going to burn those frames when we load from one can to the next. So this first one is pretty easy. Do it fit? We checked this before, but hours ago when... Yep. Great. And then the next check is that this guy still fits down there like that. Turns. You can push this button down and rotate. Let it pop back up for a full lock. And now with the bridge assembled, that's a whole ass film back. I'm gonna cut in the loading footage here from the studio, which I'll shoot next week, this coming week. So we've got the feed cassette. This is a full cassette, and we've got a take-up cassette. We've got the back, got the lid to the back, and the Darkslide. Okay. First thing I'm going to do is tear the leader pattern. The leader pattern is just like a little tongue, and then, you know, some stress relief to the other side. Take apart this canister. Okay, so I'm going to put the tongue through there, and then just wind a little bit. And you really want this straight. You don't want it cockeyed like this or like that. You just want this straight like that. Now, these cans, one is going to be upside down, one is going to be right side up. So we'll do the feed can upside down so we can lock the take-up can. Boop. Then I need about 12 or 13 inches of leader between them. The wind side will have the take-up can on it. The feed side will have the full can on it. So these are going to swap like that. And then put in just the edges of these guys oriented like this, and I'm going to work the paper into the film gate. I can just push the pressure plate back, which is on a little bit of a spring, and work the paper. I just have this in my lap, and I'm doing this upside down and backwards. I have a million shots though of me doing it in my lap, and it looks so stupid on video. So one day, okay. The thing is, gravity is working against me, so we're going to do it like this, as if the table were my lap. Okay, that's much smarter. Right, so I push the pressure plate down like this and do it like that. Cut in a future Ethan, I'm going to cut in a picture of me doing it in my lap. So when you do it at home, you can do it in your lap too, but I'm going to do it on this table. So it's for clarity, and if not brevity. Okay, I'm going to slide these guys in. Now here's how they align. They'll both align and click in. The first one you want to align is the feed side, and this this lock button aligns to like right there. Click. See that? Do that again. And, get like a close-up. It's going to click down into its thing. Perfect. And then here I want to push down and go back and forth a little bit to get the very edge of this paper under the track. There's a track here and here where it's pressed against for flatnessity. Okay, now once that's in and smooth, I'm going to push down and rotate this canister for this lock to click in right around here. Boop. All right, we're good. So now my checks are, I'm locked in here, I'm locked in here, and that this frame is totally clean and not wrinkled and inside of its tracks. Next thing I'm going to do is close the Darkslide. I'm doing that because when I close the lid lock is going to open the canisters. So we saw this in the last video. Maybe, depending upon how you're watching it, right? Inside, these are the cam lock splines. The inside features are splines that mate to these cans. The outside features are cams that mate to the body of the film back like that. And so when the lid locks onto the body, it'll open the can. So anyway, the point of that is all to say that you should put the Darkslide in before you put the lid on and open the cans. Okay, you put the lid on like that. You turn it like this. This is, again, a much better thing to do in your lap. Okay. Then you push down the lock button and you need one more hand, right? And rotate like that. If you're doing it like this, right, it's very easy, just in your lap. Right? You should do it like that. Sit down in a chair. It's very easy to load. Okay, now we're locked, loaded. We're gonna go around to the interesting side of this and roll on to the first frame. Okay, now we can set our counter. This button here, we just installed it in the last video. Push it down and the counter can swing out, and then we can spin the counter back to 0. There we go. Okay, just closed at 98. I'm gonna roll on 1. Can you get like as close up? I'll burn a frame so we can see how this works. I think we actually have this in the last set of footage. I'm ready to load this onto my camera. Let's have a look. You just put this guy in, make sure it's in there, and then close the locking tabs. I'm going to cut this paper. First of all, this back is tight enough that we're not going to expose any of the internal frames by doing this. I just wouldn't push on the Darkslide like that. Okay, then I'm going to wind this into its cassette. Push this guy, again, in your lap. It's real easy. Open that up. Now I've got this cassette is closed up with the remainder of our roll. And this is what we just shot. I'm going to stick this in the dark bag just for a second to take out the leader. So you can use that roll on a new core. I would just not adjust the frame counter, and then you can count the whole number of frames. You get about 100 on a roll. Just get the first couple of inches out like this. I'm going to pull them out. Boop. I need a straight edge right around here. In the photoprocessor assembly video, I did a demo on this, but I'm going to cut this right somewhere between this corner and this corner. You just want the flat edge. I'm going to turn this guy on, stick this guy in, and it'll click with